So today we talked about simple division using remainders. So our first problem here wants us to divide a two-digit number by a one-digit number and model that with an array. So our question says there are 12 students in a PE class and they are separated into 4 teams. How many students are on each team? So if I want to draw an array, I think about, okay, if I have 4 teams, so let's say these are my 4 teams. And now I want to divide my 12 students among them. So I could say 1, 2, 3, 4 students, 5, 6, 7, 8 students, 9, 10, 11, 12 students. So I can see that I made this 4 by 3 array. So that tells me that if I have 12 students and I divided them into 4 teams, I know how many groups I have, then I need to see how many are in each group. So in this one group, there are 3 students. So we know that the 12 is my dividend. It's kind of the group I started with, is the big pile. The 4 is my divisor, and in this case, 4 is the number of groups that I have. And then 3 is what we call our quotient. It's our answer. And in this case, it tells us the number in a group. Sometimes our quotient represents the number in a group, or it can represent the actual number of groups that we have. But in this problem, we already knew how many groups we have, which was 4. So we want to know how many would go in each group, which would be 3. Now, if we wrote this problem in a little differently and we said there are 12 students in the PE class, and instead of separating them into teams, we say something like each team has 3 students, how many teams are there? We would be doing the same problem, because here if we put them in groups of 3, and then kind of circled them in groups of 3. There's a group of 3, a group of 3, a group of 3, and a group of 3. Then we can see that we have 1, 2, 3, 4 teams. So our division sentence for that would be 12, so how many students we started with, divided into groups of 3. So this is the number in a group. Then that gives us 4 teams, which is like having our group. So we would have 4 groups. So it's the same problem. We solve it the same way. One time we're just dividing by 4 because we're putting them into 4 groups. And the other way we're dividing them into groups of 3. So let's change that problem up a little bit, and let's suppose that we had 13 students in our PE class and we wanted to put them into 4 teams. So again, I could use that same 4 by 3 array, but I know that only gives me 12, so I got to figure out how to get 13. So if I put my 4 teams, and then I want to put my 13 students, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students. Well, that makes my array, and I know that I can't put another one because then it won't make an array, so then that means I have one student over here who's kind of left over. He's remaining. He doesn't fit into my array. So when I write this number sentence, 13 divided by 4, I can see that I get 3 in each group, because an array, we want everything to be the same size. We want it to kind of be even so it forms that rectangle. So we have 3, but then we have what we call a remainder of 1. So this little guy out here is our remainder. It would be the same thing if we reversed it and said we put them in teams of 3. How many teams would there be? There would still be 4 teams and then one person left over, so one of the teams would have an uneven number. So our next problem says we're going to divide a 2-digit number by a 1-digit number, and we're going to use a tape diagram to do this one. So remember, tape diagrams, sometimes we call them bar diagrams. So we have Christy with 13 roses, and she put 6 flowers in each vase. How many vases will she use? Will there be, sorry, I didn't type this, somebody else did. Will there be any roses left over? So I want to draw my bar diagram, and I know that I'm going to label the whole thing 13 because that's my whole. And then it says I put 6 in each vase, so I know when I fill this first vase up, I've used 6 roses. And so I know I can do another set of 6. So I fill up another vase, and that's 6 roses. So I know that makes 12 roses. And so then that tells me that I have 1 rose left over. So how many vases will I use? Well, these fit in a vase. That's 1 vase. These fit in a vase. That's 2 vases. So I would need 2 vases. And then I would have 1 rose left over. It didn't fit in a vase because then our number would not stay the same. If we had written this problem a different way and said Christy has 13 roses, she divides them into 2 vases. So here would be my 2 vases. How many would be in each vase? Then this 6 tells us that's how many would be in a vase. So our last problem says we're going to divide a 2-digit number. We're going to interpret the remainder, and we want to use a tape diagram on this one. So Allison has 22 meters of fabric. It takes 3 meters to make a dress. We want to know after how many dresses is she going to need to buy more fabric. So if I make my tape diagram, and I'm going to label it as 22 because that's how I know what my hole is, then I'm going to start making dresses. So I know 1 dress takes 3, and another dress makes 3. That's 6, 9, 12, 15, 18, oops, sorry, that's a 3, 21, so I know all of this is 21, and so that leaves me with 1 meter of fabric left. So I see that she can make 1, 2, 3, 4, 5, 6, 7 dresses, so she would make 7 dresses, and then she would have 1 meter of fabric left over. So when the question says after how many dresses will she have to buy more fabric, it would be after dress number 7, she would have to buy more fabric to be able to make more dresses because she only has 1 meter left. So you are going to try 6 of these problems. You can make arrays or you can make tape diagrams to draw out and then write your answers to the division word problem.